In this video, we're going to show how to solve for the skewness of grouped data. So what is skewness? It measures the degree of asymmetry or departure from symmetry of a distribution. The formula for the skewness is Sk is equal to 3 times quantity bar x minus md over s, where Sk is the skewness, bar x is the mean, md is the median, and s is the standard deviation. So we will not be able to solve for the skewness unless we have the mean, the median, and the standard deviation. So before we solve for the skewness, we will solve first for the mean, and then next would be to solve for the median and the standard deviation. Now take note, if Sk is equal to 0, the distribution is symmetric. If Sk is greater than 0, the distribution is skewed to the right or positively skewed. And if Sk is lesser than 0, the distribution is skewed to the left or negatively skewed. Now let's take this example. Determine if the data shown below is symmetric or not. Before we proceed with our computation of the mean, let us first identify the class width. So the class width C is equal to the difference of any two consecutive lower limits or any two consecutive upper limits. So in this case, we'll just take the first two lower limits and subtract 21 minus 10 is equal to 11. So our class size is 11. Next, we're going to solve for the total frequency n, and that is by adding 10 plus 32 plus 46 plus 27 plus 15. So giving us an n equal to 130. So having these values, we now proceed to the computation of the mean. Now, the formula for finding the mean is equal to, okay, so we have here now the summation of f times xm over n, where f refers to each frequency and xm refers to the midpoint of each class interval. So how do we solve for the midpoint xm? Midpoint is simply the lower limit of the class plus its upper limit divided by 2. So if we're going to write here our x sub m, then the first row, that would be 10 plus 20 divided by 2 is equal to 15. So we can use the same formula for the rest of the intervals here, or we can just add the class width to 15. So 15 plus the class width of 11 is equal to 26, and then adding 11 to 26 gives us 37, and we add 11 to 37 to get 48, and then 48 plus 11 is 59. The next step is to get the product of f and x sub m. So we simply multiply the second column and the third column. So 10 times 15 is 150. 26 times 32 is 832. 46 times 37 is 1702. 27 times 48 is 1296. 59 times 15 is 885. Now we get the sum of f times x sub m. So we have here 4, 8, 6, 5. Now, having all this data, we're now ready to solve for the mean. So the mean is equal to the summation of fxm, which is equal to 4, 8, 6, 5 divided by our n of 130, giving us a mean of 37. Okay, so after solving for the mean, we now solve for the median. The formula for the median, if you recall, is this one. MD is equal to LMD plus C times N over 2 minus F over FMD. So we're going to use our example in order to identify all these values here. Okay, so we have the same problem, and then we have the number of children. So here we're going first to identify where is the median class. And the median class is determined by the use of the formula n over 2. So n over 2 there will give us the location, estimated location of our median class. So since our n is 130, if we divide it by 2, then our median is in the 65th to the 66th observation. Okay, so we can find that here by using our less than cumulative frequency. So for the less than cumulative frequency, we will copy the first frequency and then continually add the next frequencies. So 10 plus 32 is 42. 42 plus 46 is 88. 88 plus 27 is 115. And 115 plus 15 is 130. Now we have to make sure that this number is equal to or the same as our n. Now this column here, the less than CF column, tells us that the first 10 observations are found in the first class interval. Okay, so this is from the first to the 10th data. Here we have 11th up to the 42nd data, and here we find the 43rd to the 88th data. Since we are after the 65th, then 65th would belong to this interval. That is why we call this as our median class. Okay, so the third class interval is the median class, and this is where we get our data for our formula. So the lower boundary of the median class would be equal to, okay, so here it's 32, and between 32 and 31, so the lower limit boundary of the median class is 31.5. Then the frequency of the median class is 46. And our capital letter F would be 42. This is the cumulative frequency lower than the median class. Okay. Now, of course, our C is 11 and our N is 130. So using all these values and substituting in the formula, we have the median is equal to 31.5 plus 11, and then we have n over 2 is 65 minus we have here 42 over 46. Okay, so if you do the math, then this will be equal to, the median is equal to 37. So after solving for the median, we now proceed to finding the standard deviation. So the formula for the standard deviation is, first we need to solve for the variance S squared, and then we get the square root of the variance to give us the standard deviation. So here we have the formula is the summation of, you have now x minus bar x. So the first thing that we're going to do could be to solve for x minus bar x, and then second we're going to square this or get the square of the deviations, and then the third step would be to multiply that by our f. Okay, so we have first, second, and third before we can solve for our variance or our standard deviation. Using our example, so we have now here our table. So we need to write the column for our deviations from the mean, x sub m minus bar x. Okay, so if you remember, our bar x is equal to 37. So 15 minus 37. Okay, so I'm going to write the first one here for your as your guide. 15 minus 37 is equal to negative 22. 26 minus 37 is negative 11. Okay, and then we have 37 minus 37 is 0. 48 minus 37 is 11. 59 minus 37 is 22. In the next column, okay, I'm going to write here. In the next column, we're going to square the deviations from the mean. Okay, so negative 22 squared would be 484. Negative 11 squared is 121. 0 squared is 0. 11 squared is 121. And 22 squared is 484. Then here would be our third step, which is to multiply the square deviations from the mean by our frequency. So this number on this would be multiplied to get our value here. So 10 times 484 would be 4840. 32 times 121 is 3872. 0 times 46, that would be 0. 27 times 121 is 3267. And 15 times 484 is 7260. Step number 4 is to get the total of the last column, and that would give us 19239. So we're going to use these values in our formula. So solving for the standard deviation, okay, so we have here now the value of 19,239 divided by 130 minus 1, which gives us, okay, where am I? So which gives us here a value of 149.1. So our S would be equal to the square root of 149.1, which is equal to 12.2. Okay, so we now have the values for our mean, median, and standard deviation. So our mean is 37, the median is 37, and our S is 12.2. So substituting in the equation here, we will have 3 times the mean of 37 minus the median of 37 divided by our standard deviation of 12.2, giving us an SK equal to 0. Now, to answer the question if the data is symmetric or not, then since SK is equal to 0, then we have the distribution is symmetric. Okay, thank you, and I hope that you have understood our explanation.